Hi everyone, my name is Varshal and my teammates Sanket and Viraj. We are the students of Sardar Patel Institute of Technology, currently pursuing BTech in Computer Engineering final year students. As a final year student, we had to do a major project. So for that, we have built an application called video streaming, which is similar like YouTube, but focuses on a problem of video buffering. So for that, we are using an HLS technology in order to reduce the video buffering. So let me explain you the complete process via this diagram. So for example, if a user wants to upload a video in the background, an API call will be done to AWS, which will return a sign URL. On that sign URL, the user will upload a video and that video will be stored inside the bucket. As soon as the video is completely stored on the bucket, an event will be triggered, which will call a lambda function, so that the video is been taken from the temporary bucket and stored inside the queue. There will be a consumer running, which will continuously poll the queue. As soon as a video is been found here, it will take that and increase the count of the redis in order to let us know that how many processes like or a video are currently being rendered. So it will create an ECS instance, which will be a Docker file, Docker container. Inside it will do the real transcoding. So what's a video transcoding is converting a video into different resolutions. For example, if our video is 1080p, it will convert it into different formats. For example, 360p, 480p, 720p, in such a way. And using HLS, what it will do is it will take one video, it will divide that into different segments, and based on that segment, we can directly render the video in order rather less loading the complete video. I will make you understand with the help of an example. And after the complete process, it will be stored inside the final bucket. Let me show you the real demonstration of the process. So for that, this is our application. Here you can see an upload button. The user has to click on the upload button. Here he has to provide three fields. First, the video, title, and the description. So let me upload the video. Let me add the title for the video, and let me add the short description of the video. So I will click on the upload video button, which will upload the video to my AWS server. So now it's been currently uploading my video. So now it's giving me an alert that video has been uploaded. You can see now there is no video. So let me show you the how it works. So I will refresh the cluster. Here you can see that there is one new task. So let me open that task. So the current status of the task is pending. Also inside the My Videos tab, you can see that our video is getting processed. So here you can see that the videos which have a green mark are being published and having a orange mark are being currently being processed. So you can see that the status has been changed. Now it is running. And let me show you the logs of that video. So we are currently using CloudWatch for getting the logs of the video. Here you can see that the processing has been started, the video has been downloaded, subtitles has been generated, and the thumbnail also has been generated. So what we are trying to do is taking the video from user, transcoding it into different resolutions such as 360p, 480p, 1080p, 720p using HLS technology. Plus, we are adding a features of generating subtitles, and generating thumbnail using AI. So this process is little uh, more time consuming. So let me skip this video. Skip the so let me skip this part, and I will be back again after the video transcoding has been completed. So as you can see that our transcoding has been completed successfully. Here the video are been converted to 360p, 480p, and 720p and 1080p. And finally, the complete state of the video is been updated and stored inside the database, and the raw object is been deleted also. Also, I wanted to tell you one thing that for storing the thumbnail, we are using Cloudinary, and for conversion, I mean video transcoding service, we are using FFmpeg and HLS technology. Also, I wanted to show that how actually the HLS works. So let me go inside the final bucket in which we are storing the complete videos. So this is the video which we have uploaded currently. Inside that you can see that there are multiple folders. So this is the subtitle file, this is the index file, and there are multiple resolutions. So this playlist.m3 UIT file helps us to understand, for example, if the user is watching the video in an auto resolution, so it will detect the bandwidth of the video, and based on that it will render any of the fourth video. Like if the bandwidth is low, it will automatically detect that using HLS and render 360p video. If the bandwidth is good enough, it will render 1080p or 720p. So based on that it will identify the bandwidth of the network. So if I go inside 360p, here you can see there are multiple TS files. So these files are also called as a segment file of a video. So I was telling before that a video is there and it is been divided into small segments. So these small segments are the TS files, and there is one index.m3 UIT file. So what the use of that file is, for example, if you are watching a video of 20 minutes, right? And if you want to start the streaming of that video from 10 minutes, so it's unnecessary to load the video from 0 to 20 minutes, right? So what we are doing is at 10 minutes, we will identify which packet has to be sent to the user. So this will help us to save the bandwidth of our server and user both. So at the time duration 10, which packet has to be thrown, the HLS will identify and it will throw that packet to the user. So this way we are streaming the video. So now let's refresh the app and see whether it's done or not. Also, you can see that the thumbnail is been generated, right? And also the video status has been completed. So for thumbnail generation, we are using an AI which uses internally Laplacian algorithm to identify the best frame. And now let's play the video. So I don't know if you can hear the audio. So here you can see that we are rendering the video, the title, the person who uploaded the video, the short description, and the AI summary tab. So here you can see the three dots, right? While on clicking that, you can turn on the subtitles which are generated by us itself using AI, or you can turn off the subtitle on your wish. Then there is an option of video quality, right? So here you can select the quality I shown you before, right? 360p, 720p, 480p. Yep, these are all that resolutions. You can adjust according to you, or you can set auto, so it will identify the bandwidth and stream the video smoothly. But but you will face some quality change in auto, right? So you can do all that stuff here. So let me play the video. You can see here that the subtitles are being played. Also, if you move the cursor ahead, it won't stop more. It will start playing the video. Here is a short description of the video, and there is a tab called AI summary. So how does the summary is generated? So let me explain. So for that we are using a Gemini model. We are passing two parameters. One, the description of the video, and the subtitle which we have generated for that video. Using both, it generates a short summary. So if I click here, it will start generating the summary. Um, Due to some reason, it's getting failed. I don't know. I have to check that again. But yeah, it works in the same way that we have to provide two parameters. One is the description of the video and the subtitle. Moreover, we have the tab called My Videos where the user can see which videos he has uploaded and at what date and how many views he has. Then we have a profile section where the user can log out if he want, and there is a dark mode option too. So if he wants dark mode, he can just turn on the tab and he can view the complete app in dark mode. So yeah, this is our application which we have built during our major project. Thank you.